Have you ever wondered what's really going on inside an AI's mind? For the longest time, even the people who build them have basically treated them like a black box. We know they work, but we don't always know why. Well, a really groundbreaking paper from Anthropic has given us a new key to unlock that box. So let's dive in and unpack what they found and what it all means for making AI safer.
Okay, so to really get a handle on the problem, let's start with a dream scenario. Let's imagine the perfect, simplest AI model. What would it look like on the inside? How would it organize information?
And this right here, this is the dream of AI interpretability. It's just so clean, so simple. One neuron, one job. You'd have a dog snout neuron, and it would only fire when it sees a dog snout, nothing else. It's a beautiful, logical system that we could easily understand.
Yeah, it would be great if that's how it worked, wouldn't it? But unfortunately, no, not even close. The reality is much, much messier. And that messiness is one of the single biggest challenges in AI safety today.
So when researchers actually crack open a real-world neural network, they don't find that clean one-to-one mapping. What they find instead is, well, it's kind of a confusing jumble. They find this thing called polysumanticity. And really, this is the core of the whole black box problem. It means a single neuron isn't just a simple dog snout detector anymore. It's firing for dog snouts, and for car tires, and for the color blue, all at the same time. And this is where it gets really serious. I mean, think about it. If we can't figure out why a model is making a decision, how can we ever fully trust it? This isn't just some interesting academic puzzle, it's a fundamental roadblock to building AI systems that are safe and reliable. So to figure this all out, the Anthropic researchers did something brilliant. Instead of trying to dissect a massive, complicated model, they built their own tiny, simplified neural network from scratch. They called it a toy model. This let them control all the variables and just watch what happened in a controlled environment. And by watching their little toy model, they found something amazing. That messy-looking polysemanticity, it's not random at all. There's actually a hidden logic to it. And the key to understanding that logic comes from, of all places, physics. The big reveal, the aha moment of the paper, is superposition. The model isn't being chaotic. It's being incredibly efficient. It's packing different concepts together in a very specific, structured way. Think of it like this. Imagine you have to pack for a month-long trip, but you only have a tiny backpack. You can't just throw everything in. You have to get clever, right? You roll your clothes, stuff socks into shoes. You compress information to save space. That's what the AI is doing. It's using superposition to represent more features than it has neurons by packing them together. And this image from the paper shows it perfectly. On the left, you've got features that show up all the time. The model gives them their own space. But watch what happens as we move to the right. As the features get rarer or sparser, the model has to get efficient. It realizes it can save a ton of space by packing them together, compressing 5 different concepts into the geometric shape of a pentagon using just 2 little dimensions. It's wild. So you can see the trade-off here. Without superposition, a model is easy to read, but it needs a ton of neurons, super inefficient. With superposition, it becomes an incredible information compressor. But now each neuron is a multitasker. It's handling a piece of many different concepts, which makes it way harder for us to interpret. And this image illustrates the paper's coolest hypothesis. The messy, confusing network that we can actually observe, it's just a shadow. It's a compressed, low-dimensional projection of a massive, perfectly clean and logical network that we can't see. So we're not really looking at a mess. We're just seeing the distorted shadow of a much bigger, more coherent structure. Now, what makes this discovery so powerful is that it's not just a description of what's happening, it's actually a predictive theory. It turns out the switch to using superposition isn't gradual. It happens all at once, in a way we can forecast. The researchers found that as you change certain conditions, like how rare a feature is, the model will suddenly just flip its strategy. They call it a phase change, and it's a perfect analogy. It's just like how H2O suddenly changes from liquid water to solid ice at a specific temperature. It's a fundamental law of the system. And this slide right here is the proof. The chart on the right shows their theoretical prediction. It's the math saying when a feature should be ignored, get its own neuron, or get packed into superposition. And the chart on the left, that's what actually happened in their experiment. They're a near perfect match. This is just stunning confirmation that their theory isn't just a guess. It's a predictable, fundamental law of how these networks learn. Okay, so this is all incredibly cool research.
But why is it such a huge deal for AI alignment and safety? What does it actually mean for us?
Well, before this paper, polysemanticity was just this big, messy problem. Now we have a theory for why it happens. That's a game changer. It means we can start to predict how a model might develop hidden, unintended behaviors. What if a really dangerous feature, like deception, gets packed into superposition with a common, harmless feature? The model could be learning something bad right under our noses. This research gives us a map to start looking for those hidden connections.
Ultimately, if polysemanticity is like a compressed language that the AI is speaking, then this research is our first dictionary. By learning to decode superposition, we're taking the first real steps toward being able to truly understand how an AI thinks, not just what it outputs.
And that, of course, brings us to the final, most important question. Understanding is the first step, but it's not the last. Cracking open the black box gives us incredible insight, but the bigger challenge of alignment, making sure an AI's internal reasoning is compatible with human values, well, that challenge is really just beginning.
And just a reminder, this is for entertainment purposes only.